Hello, welcome to DETNET at the online IETF 110. I'm Lou Berger. We have with us Janusz Farkas and Ethan Grossman, our secretary. The material is, should be all posted, actually for both sessions. And there's a link in the chat to help get you to the Cody MD, which we're using for minute taking. And if you can help us sort of crowdsource those minute takings, we'd really appreciate it. The same information was just sent to the list. So please jump on Cody MD and help us take notes. Let's see if I can get this thing to change slides. There we go. As we are at the IETF, we have sort of ground rules governing the way we interact, and also the information, how we share the information we say in these working groups. Basically, anything you say here becomes part of our record. If you're not familiar with the Note Well, I strongly suggest that you go familiarize yourself with it. So if you're hearing this, obviously you're here with me on Meet Echo, so you figured out the first part. We're using the integrated Jabber and chat, and we'll try to watch that and channel any of the any comments there. If you want to make sure something gets to be repeated, please make sure to put @mic in front of it. We'll try to track that and repeat the comments. I already mentioned that we're taking notes through Cody MD, and the material is posted at the various links. One thing I'd like to comment is the tools website seems to be having a whole slew of issues, and if you run into problems there, go check out for the same information on Data Tracker. So we have 2+1 sessions at this meeting. The first session we're in now is a 1-hour session. We're going to really focus on reviewing where we are on our Yang document, which we hope to move to last call. The objective of covering that now is to really make sure the working group has a good understanding of what's there, and to accelerate the last call process. Our second session is tomorrow, another 1-hour session, and it's sort of a normal working group meeting where we'll cover the drafts that are on the agenda. The third session is a joint meeting with PALS, MPLS, and Spring, and is really going to be focused on OAM and MPLS and the control word consistency across the different groups that are using that based technology. So I guess I should have made the comment about Yang on this slide. So today we have the Yang walkthrough, and you can see the agenda that's laid out for tomorrow. In this working group, we follow an IPR disclosure process. That is, we require IPR statements from authors and contributors at 2 points. The first point is when we adopt a working group document, and the second one is before we submit to the ISG. So that's part of our last call process, working group last call process. Those are required steps, and we require responses from all listed authors and contributors before moving to the next step. We are also introducing a new step. This is not a requirement, but a request. And specifically that we ask that if you are added to a working group document as either a contributor or as an author, that you make a statement at that time. Now, you'll be required to make a statement at last call, but since you didn't participate in the initial IPR call process during adoption, we ask that you make a disclosure at the time of being added. And that's just for working group documents. So we've had a good set of documents published. It's always good to see publications and new RFCs. We thank all those who contributed to this, and all that's pretty much everyone in the working group, because even if you just make a single comment, that's a contribution, and we appreciate that. We also have a good set of documents in the RFC editor queue. Together, between the published and what's in the RFC editor queue, that makes up the core data plane of DETNet and represents a really significant achievement. So that's great that comes out. From our initial set of deliverables, the main item that is left is the Yang document, and as you heard earlier, we are preparing to last call that document as well. We have the informational bounded latency document that's post working group last call. We have the Yang document headed to last call, and we have several documents that are not on the agenda. We do consider these fairly important documents as well, so we look to them progressing as rapidly as possible. We have one document that you're going to hear about later that's being requested for working group adoption. At this point, we're all used to working remote, probably a little tired of it, and looking forward to hopefully not too long being in person. But until then, we encourage everyone to continue using the list. Discussion there is really the primary place for resolving issues. We can also schedule working group meetings and then less formal working meetings. I believe there are going to be 2 less formal meetings spinning up. There's the Yang. There's a weekly Yang call that's been going on. I think that one is going to wind down, and we're expecting that there's going to be one on control plane and one on OAM. Those meetings are open to everyone. They're less formal, so they're not minuted, but what goes on there will translate to updates to drafts, and those drafts will be brought to the working group, and the changes will be brought to the working group to ensure that we have consensus from the working group. But again, those are going to be open to all, and stay tuned to the list for the announcement of those meetings. And with that, we're done with the intro. And we're going to go on to the the Yang model. This is going to be the rest of this session. And I believe, Don, you said you're going to be presenting this. Just make sure to say next, and so I know to flip to the next one. Over to you, Don.
Sure. You hear me okay? Yes?
Yes, I can hear you fine.
Okay, thanks. So this is the Yang model. I'll just state that I'm not aware of any IPR because I joined the draft at some period after it was adopted as a working group document. So the list of authors on there, and we've, like Lou had mentioned, we've had weekly meetings pretty much throughout the year. If you go to the next chart. So we think the document's at a point where we're ready for last group call. We've had in other updates, we've always had items that we had to do. We are going to present the summary today, and as always, please review and comment. So one of the things I'm going to do today is try and help you understand how we approach the document and help you perhaps get any review comments in. Next chart, please.
One comment on your prior slide. The title of the prior slide said configuration. My memory is the current model covers both configuration and operational state.
Yes, yes. So there is, and the name of the model was called a config model, and then we changed it just to DETNet Yang. So there is both status information and configuration information in there. so because this this model is primarily configuring the data plane, though the majority of the items are configuration items. So the history there is, as we went through the various versions, so we're on version 10 and 11 are virtually the same, except that somewhere along the lines, I guess I didn't catch that there was additional Yang checks that went in. So when I submitted 10, I found that there's a -IETF flag I hadn't been using on the Yang, the PyYang tool, and that turned up a bunch of other basically comments on descriptions that were missing. So we edited that, and we have a clean Yang model. Next chart, please. So the Detnet architecture is published, and this diagram is in there in ASCII text. And as we were trying to present this, I realized that if you think about the data plane drafts, they go right across this architecture kind of horizontally. And the same thing for the flow model. It talks about flows that are dealt with, the attributes that are dealt with them horizontally. But the Yang model is actually kind of operating vertically in the stack on each one of these devices. So depending upon where you are, you're using different attributes in the Yang model, and that's what we're covering. So we're covering the data planes defined in the IETF and the cases in the IETF, and there's corresponding Yang that we haven't really looked at in this that would be for TSN that's being in the IEEE 802.1 working group. So we've been concentrating on what we documented and trying to stick to the data planes, et cetera, that are in there. Okay, next chart. So this chart we've seen before, and the flow model is a functional model that talks about the flows, and it talks about application flows, the DETNET flows, and the service, and we've translated that into the various pieces in the architecture. The only thing that's happened in the last little while, in the past few months, there was some updating of some fields in there, and we have tracked those changes, we believe, in the Yang model to date. So next chart, please. So like I said, the Detnet Yang model is hierarchical. It contains aggregation. It's location dependent. We saw on the chart where you are, if you're an endpoint, transit, or relay. The flows are aggregate flows, and we capture the flow attributes and the status information that's in there. We tried to build it as much as possible on reusable pieces from other Yang models were out there for IP and MPLS. It's configuration centric because it's a model that would be used with something like an SDN control plane. We're not talking about configuration for internal control planes, and it includes some operational attributes. The DETNET flow model, I'm not really summarizing that well, but the differences are that it's functional, and it's concerned with the attributes and characteristics of flows, and it covers configuration aspects and operational aspects. So that's just kind of, when I came into this, one of my tasks was to try to align with the flow model, and we think we've done that, but there are differences, as I've mentioned out. Okay, next chart, please. So the methodology we used, we had a large model, and we had many permutations. And what we found, at least I found, it was hard to validate by simple inspection, and we needed to enumerate the various cases. So we went through trying to align the terminology with the documents, and trying to reuse the pieces that were out there. And what we found worked was considering configuration cases. So we started off, once we had revamped the model, we started off with a simple configuration case of a flow starting in an application, going through the service sublayer, going through the forwarding sublayer, and then we used Yanglint to test and document that case. So by providing an XML file that had the configuration aspects for the particular case we were looking at, we could go through and validate that against the schema, and it gives you a clearer picture. And because we had discussions back and forth, we've provided diagrams for the cases. So we've got, like I said, we started off with the basic single DETNET flow endpoint for unidirectional and bidirectional cases. And then we started working our way through the different cases, transit nodes and simple aggregation and aggregation at several places. Next chart, please. So we've seen this chart before, and it's kind of a map of what we've done. So we have at the top there, we've got IP and an IP flow coming in. IP could be IP all the way through DETNET. It could be application service sublayer or forwarding sublayer, and it could come all the way through. Or IP could be encapsulated at MPLS at the service sublayer, and it could continue its way on MPLS, and then of course return to IP at the outside. Or it could be that IP went over MPLS, and then that went over an IP tunnel. We don't have everything for IP tunnels in there, and IP tunnels, because we don't have any, at this point, we don't have any DETNET drafts that specify those. So MPLS, you could come in as MPLS and you could just pass through as MPLS all the way. Ethernet, we have the model where Ethernet comes in and we can look at it at an interface, and we can filter it somewhat, and then we would pass it on over. MPLS is the typical case today, but it could go in an IP tunnel in the future as well. So we've highlighted the documents that we've covered, and for this base draft, this is what we're thinking is necessary to cover. The question we have is there anything we think we should be doing for the IP and IP tunnels? That's the only piece we think that it's a complete document as it is, but we wanted to highlight that point. Next chart.
Do you want to take comments as you go? Do you want to take comments at the end?
Well, if there's any comments on that particular piece right now, it would be worthwhile.
Just giving people a moment to get into queue. I guess my question, I don't know which hat I'm wearing, is where is IP and IP tunnels documented?
That was our issue, that we didn't have good pointers to it for DETNET. Now, if there's a document that somebody finds somewhere else that they think we could incorporate easily, we'd be happy to look at it. But we were struggling with finding a good pointer to go by.
So I think there's your answer.
Yeah.
All right. Thanks.
Okay. Next chart, please. So this is just a model structure that we have in the document. So we have application flows, the service sublayer, and the forwarding sublayer, and then we originally had under each we tried to fit in with the flow model. We tried to fit in the aspects. As the model evolved, we basically created a traffic profile that has the flow attributes, and it could be optionally attached to each piece. Because DETNet is hierarchical, but an app flow and a service sublayer flow and a forwarding sublayer flow can go on to the next layer. We found that there were cases that they could be attached to each one. They're optional in the sense they don't have to be there, but you could attach that information to, if you had app flows and then you had an aggregation, you could have a traffic profile that reflected that aggregation at the service sublayer, for example. So this was this is what's the major pieces inside the model are these. The app flow, the service sublayer, the forwarding sublayer, and the traffic flow profile. The other thing is that in the model that we do is we refer to each layer with reference pointers, and they're bidirectional reference pointers, but we've tried to make it so that you only have to configure it in one direction, and the other direction would be just something that you could refer to. So if an app flow refers to a service sublayer, but you would only configure it in one place, and the other one would be available for viewing on the other side. So you're able to see from the app flow which service sublayer you're going to, and you're able to see from the service sublayer what app flow it supports, but you only have to configure that once. Next chart. So the model tree is in the document. I just put it here for reference because we're going to be referring to pieces inside here. And the only thing you really need to take away from this is when we look at the models in the Yanglint, where we're doing the actual cases, we're using a subset of these models. So these have all the this has all the permutations in it, and what we have here, just on the left-hand side, we have the traffic profile, and then we have the app flows. Next chart, please. We have the service sublayer with its attributes and direction. And next chart, please. And then we have the forwarding sublayer with its attributes and directions. And next chart. Okay. So at a high level, that's the complete model, and now what we're going to talk about is the various cases. So what we started here with was a simple model, and we started with the application flows. So the diagrams that we've created to describe this have evolved over time. We've tried to align them one with one with the examples. So there is a repository, a DETNet repository that contains, I think, the complete set of these diagrams and the complete set of the test cases. The only thing that may be a little bit confusing, and that was one of the reviews had said, oh, you're using IPv4 addresses all over the place, and they're the same. And I didn't realize we had done that specifically in the models and the examples to match these diagrams, and I changed some of them. But for this presentation, I think I've realigned them. But if you're looking at the draft and you say, oh, the addresses are different, it was just because there was a comment that you should vary the addresses, and I foolishly followed the comment. So in this diagram, what we have is we have two applications, and that's illustrated. We tried to use a consistent representation all the time. So we've got data, that two applications being aggregated in an IP, and so the rest of the way through, there's a replication function that's going on here, but the rest of the way through, those application flows are basically encapsulated in that IP service layer all the way through, and the rest of the information is through there. And if you're looking at the configuration for this, you're looking at it only at one of these points. You have to, of course, go to each node and have the configuration at each point. We have only done the configuration at selective points in the diagram. So that's that vertical aspect that I pointed to before. You really have to look at context of what node you're going on there. Next chart, please. So this is, I think this is just the same. Go back for 1 second. This is two apps. I think this is the same diagram. Just go back again to the forward. Sorry. Yeah. This is just another representation of the same diagram we just had, and it's just another way to show it. So we're basically showing the operations that go on here at a node, the ingress node, the application service and forwarding layer, and then again you'd have the same operations on the egress, and there's configuration in both directions. So while this is bidirectional, you can configure it either as like a unidirectional configuration in two ways, or there are capabilities in the model to basically use, if you're bidirectionally congruent, you could use the same components in both directions, but there's nothing in the model that forces you to. So it's a unidirectional type of configuration, but you can support bidirectional services as well. Next chart. So this is another case here where now we're doing, let's see, make sure I get it right. We've got two applications coming in, and we're doing the, we have two IP so the applications come in, the data comes in, and it's on IP, and these two IP applications are being aggregated at an MPLS service layer. Okay. Next chart. So this is how we would validate a case here. This is case B1, and it says continued on there. No, I think that's the first one, but it looks like it's the beginning of it.
Just clarify something on the previous slide. Sorry about being on mute. So on the previous slide, your word said that you're aggregating at the service level, but the slide says aggregating at the forwarding level. Which one is it? Did he misspeak, or is the slide wrong?
I probably misspoke.
Okay, thank you. So this is aggregation at the forwarding sublayer.
Yes, I think so.
All right, thank you.
And can you just go to the next chart here? It looks like we've got the charts, and yeah. So this is the actual first chart, and then they somehow got out of order. Probably my fault. So what I wanted to cover here is that as much as possible, we validated as much of the model as we could. So we actually configure interfaces, and we're using the operational view of the model because to get a view of what's going on, we have both config false and config true attributes. When you're configuring in Yang, you basically, the config true items are the ones that you are typically configuring, and the config false ones are typically the ones that you're reading back for status information or, you know, confirmation of configuration. And we wanted to do both because we found that if you just do the config items, you don't quite have the full picture. You don't have these forward and backward pointers that we were mentioning. So we've gone to a model where we're using the operational one, and for that reason we have to fill in, because the IETF models have some pieces in there, we have to fill in these things like the operational status and the time just to satisfy the model. So that's why there's more detail in here than there needs to be. You really just need to know the name of the interface. But because we're going to use that and we have an operational view, it will show up this way in the model. And then on the right-hand side, we have the applications here. Sorry, nope, stay there. So we have the application, and we have the application's names. And then like I said, we've got these pointers, the reference pointer. So the outgoing service, we've called it service sublayer -1, and the traffic profile that it's associated with. And then you see some status information. So we said it's all working and ready, but that's just data that we're punching into the model. And the interface, so the interface, like I said, to get that interface and reference it in, Yanglint is actually checking these. So if I was to put Ethernet interface 5 in, it would say it doesn't exist. So that aspect of the model is being checked in here. But it also gives you the nice flow through of what's going on here. So we have the IP flow and the addresses in here, and then the same for application 2. So now I believe you have to go back one chart to get to the second chart. Yes. So here's the traffic profiles follow next, and we have the profile, and then we have in this one we have traffic requirements. There are in the third one down, we have some flow spec capabilities. You can populate it with the traffic requirements or the flow spec or both or neither. And then we have, as I mentioned before, we have pointers to the applications that are members of this. And then in the application, we saw that we had a pointer to the traffic profile. And then on the right-hand side, we have the service sublayer. So we have, again, the service sublayer name, and it has a traffic profile and the operation type that it's doing. And then it has the application flow that's in there. And then it has the outgoing type where it's going to the forwarding sublayer, and it's the index and any labels that we've got on there. And these labels should match the diagram. I'm not 100% sure they do, but we did check them, and we think they do. And then it has the reference for the forwarding layer. So if we skip 2 charts forward, So there's the other service sublayer, and then we're on to the forwarding sublayer. So we have the forwarding sublayer, and again, just like you saw with the other ones, the name, the traffic profile, the operation type, the service sublayers that are aggregated in this, we can see that. And then the outgoing interface, it's going to one of these interfaces and the labels that go on there. So if you understand this, you basically understand how the configuration model works for a particular case, and the rest of the presentation, we didn't go through this for every one of these, but these, like I said, are published on GitHub. We can publish a pointer to that if you want. They're just to help you understand the model. So if you're really a good Yang expert, you'll just look at the Yang model and know what's going on. If you want to understand how it's used in configuration, these are the things that you would go and look at. So I can pause there for any questions. This is the diagram that goes with that. So like I say, we've done the validation, and then we've done the diagram for all of these cases. And I'd like to thank the members that were participating in the weekly meetings for going through all these, because it takes a while to go through all these and get that working. But I think it provides a good way to view the Yang model. Any comments, questions?
Don, these are not in the working group document, correct?
The diagrams?
Yes.
Yeah, no, we didn't put. We put a couple of test test files. So I think it's A1, B1, and B2. The tests are in there because other Yang documents typically include some sample configuration, and we validated that through Yanglint. So we have done that, but we haven't put the diagrams in because they're not an ASCII art, and I think
they
it
don't
would
have to be. You could
Yeah.
you could publish them as an appendix, or just include them, and they would be included in the PDF. I myself haven't done that, so I'm not quite sure how that works from the mechanical processing. But I know you can do it if you want to. Just something to consider is if you think this is really useful in helping understand things, you might want to figure out how to capture it in the document. There is one also comment from Jabber. This is from Tim Costello. Are any other Yang models for DETNET outside of the IETF? I think that, are there any defined for DETNET outside of the IETF? And then the follow-up is, this Yang model interoperable with other DETNET Yang models from outside the IETF?
So there are TSN Yang models that are being defined in the IEEE, but those are not DETNET Yang models. Those are TSN ones. So I'm not aware of any DETNET Yang models that are being defined outside the IETF that are in the public space. So the second part of that question would be they're not interoperable. But when you talk about interoperability in Yang, I'm not exactly sure what you're talking about. The data plane between the way this is implemented is you would configure on one node, you configure on another node, but the data plane that goes between that is standards. It's either MPLS or IP right now, and that would be interoperable. So I don't know what interoperable means in the sense of Yang models in this question, if they want to clarify. But
this wants to get in queue, great. If they want to follow up in Jabber, that's fine. But right now, I don't see either of them.
Right. Okay. So next chart. So these are the cases we went through. So I think people can read through the cases. Basically, we considered aggregation at each layer, and the model has. So what when we were discussing this, we found out that DetNet is very recursive in the way it works. You can take an application, and somebody's application comes in and goes into a service, and then that service can be either a service that goes to a forwarding layer, or it can be a service that peers with other services, or it can be a service that becomes basically an application to the service. So we worked through each one of those cases, and we came up with a branch that would allow us to do that. And so you do get, there is a question on the list. I don't know if Balaz is on here. He may step up at the end and have some discussion. But he had some questions about Ethernet going on to these models. And for Ethernet, we basically consider Ethernet as an interface, and we have some attributes on the Ethernet that could filter it down to like a VLAN, say, or a particular address, and then it's carried transparently across the network. We don't do anything else with Ethernet because that's not part of the DetNet documents that we have, but we do carry that across there. And so the point is that when you're reviewing this, just look through the models and see if you think that they make sense, and if you think of anything else that you think is missing, please raise it on the list. I have replied to Balaz about the Ethernet pieces, but I may not have hit his points on there. So next chart. So this is again just each one of these charts has a diagram like this, just showing the aggregation, how it's going on at the different places. So if you're aggregating at the service layer versus the forwarding layer, that's the case that we're handling. Go on to the next chart. And so this is aggregation. In this case, we have forwarding sublayers here, and we are aggregating DetNet flows 1, 2 into a forwarding sublayer. Go on to the next chart. And this is basically showing what's happening again. In this case, we have, you can see the forwarding sublayer being aggregated into a service, and then aggregated into 2 forwarding layers. So just go on to the next chart. I think these charts speak to themselves. This is just showing the reverse direction for that one. Next chart. So C2 is a relay node. You can go on to the next chart. And the corresponding aggregation diagram for that, what's going on there. So, we can just go through these charts. There's nothing at this point that I'm not going to deal with each one, but if there's any questions that you have now or on the list about these diagrams, please feel free to raise them. Go on to the next chart. Yeah, that's just the disaggregation. So we've got the relay node, and this one is aggregating service sublayers into a service sublayer. So go on again. So this one shows where the aggregation is happening. And next chart, just the reverse direction. Go on. And now this is a relay node, similar one again. You can just flip through this chart.
Are you going to have any slides that cover just the IP only case? Or is everything IP over MPLS in the examples?
I don't think we have one that covers the IP only. The IP only, there's not much difference. Just the forwarding, if you go back to the, I guess you'd have to go back to the tree model if you want to look at it, but I can point out the differences if you'd like.
Maybe we'll do
really,
that. Maybe we'll do it at the end.
Yeah. Well, we're basically, there's nothing here more than examples. We really just wanted people to be able to compare with these charts, you know, understand what's going on, and you know, I don't think that there's really any more value in going through the charts other than to say that, you know, the value you get about them is holding up the two of them together and saying, okay, I see the difference here, and then I can see the difference in the configuration. Okay, so we can go on. So we can either keep going through, I think we've got about it.
There is
Yes.
a question in the chat window. Are these configurations inspired by particular use cases, known scenarios, and topologies? This is coming from Eve.
So certainly some of them are inspired by real use cases because you want to be able to aggregate at each layer. But some of them it started to fall out because the nature of the Yang model. Once you aggregate something at the service layer and you allow services to come in, you end up with these this hierarchical nature, but then being able to plug and play them in there. So they were definitely inspired by real use cases, but I think the model supports perhaps more aggregation types than you would need, in the sense of doing that on a particular node. You can always do this step by step by adding another node with configuration to, like, you start an application again, you have something aggregated, but then it comes in as an application, and you could do it that way. So I don't think there's unnecessary pieces in there, but there are pieces that would be less used and pieces that would be more used in the model, I would say.
Thank you, Don. If you have anything further.
Yeah, the rest of the presentation, really, I mean, if we want to just go back to Lou's point and just show where an IP model would be in there. If people think that, you know, we need an IP model example, that's not hard to oh, let's go back. Yeah. No, yeah, right. Sorry, no, the tree. Well,
so I can't, if you give me a slide number, I can get there.
Okay. Well, essentially, this diagram here would actually show. So your question was, have we done mostly MPLS? And we've done mostly MPLS, going onto the MPLS path. But the IP path would basically just have the service sublayer labels being IP and the forwarding sublayer being IP. So if you go next chart, and next chart, right here. So this is the application, next chart. So the service sublayer here, if you look midway on the screen, it says service ID and it says DETNET flow type. If you're an IP DETNET flow type, you configure the IP addresses in these parts. If you're an MPLS flow type, you configure it later on. So basically, the difference between IP and MPLS is right there. It's captured right there. That's for the incoming direction, and then for the outgoing type, it's the same thing. We have the header type, if it's an MPLS header or if it's an IP header on the right-hand side, you would configure it as an IP header. So that's the only difference in the model between doing an all IP and an MPLS one. The other thing about the IP is because you can specify prefixes on the input of the IP, you can do some aggregation with IP prefixes in the IP model. So we don't have, like we said, the IP and IP tunnels, but we do have aggregating prefixes on the incoming side, so you could do that.
So maybe in summary, I can say that the Yang model itself supports the DETNET IP data plane. You just rolled out in the presentation more MPLS examples.
Yeah, and that was probably just habit. There was no reason for that other than habit.
If you do end up putting this material into an appendix, I think it would be good to include some IP, pure IP examples, both for the normal case and the aggregated case. And I see we have David Black in queue.
Okay.
I would agree with your remarks. One of the nice things about the MPLS data plane is every time you do the aggregation, you've got a label that shows you the aggregation. The IP data plane has to do some of this implicitly. So starting from MPLS, at the very least, leads to clarity in this discussion. And then writing up the IP examples that would be useful, and maybe if we find serious gaps there, it might lead to somebody trying to figure out how to do an IP and IP data plane to fill the gaps. We need to understand what the gaps are first.
Yeah, we don't think there's any gaps from an IP perspective, but you know, we can definitely spin up a test case to make sure. And the question, I guess, is do people find, you know, we put a few example models in. We didn't want to bloat the document with it, but if people really find that, hey, this I don't know what you call it, dictionary of examples basically is really useful, and we should capture it in the document, that's good information to have too.
I'm certainly finding it very useful, and in particular, the pleasant surprise I wasn't expecting is that it provides a solid foundation to understand what this aggregation looks like in the IP data plane, where we don't have the ability to add additional addressing info.
Okay. I see Bella's in the queue.
Yes, Don, thank you very much for the summary. So my question on the list was related to the subnetwork scenarios, but now in your presentation you have also highlighted that this is out of scope in the current Yang model. So where I was somewhat worried is if we are using, for example, a TSN subnetwork, and the DETNET node is a TSN-aware DETNET node as defined in the drafts. Then you need some mapping between the DETNET flows and the TSN streams. And I think this is a point where IEEE specified Young model and IETF specified Young model have to find a common connection point. So that was my major question on the list regarding the subnetwork scenarios. But as I understand now, it is some further work.
Okay.
A follow-on to that is other large Yang models have sometimes written a section about future augmentation. So clearly there's going to be definitions for TSN. If you attended RAW earlier today, you would have heard them talking about building on the base DETNet model. So they might have some definitions. So it would be good to have a section, sort of an informative section for the future model designers, that, you know, the derivative model designers, to talk about how you envision augmentations for technology specifics. You know, where they would end up plugging into this model, or whether they'd be their own model, however you see it being done.
All right. Well, that's all I have. If there's no more questions.
There is one more note on in the chat that examples are very informative. We should add them.
Okay. I also saw Andy Mellis says you can redraw the diagrams in SVG. I don't know whether he was joking on that, but
Also have PowerPoint exported as SVG, I'm pretty sure. We have Torless.
is that the oh, okay, you can.
Yeah, it's just one that if you do it in SVG, it can map to many formats, and I guess the implication there is that the tooling likes SVG. But we're running out of time, so Torless is in queue.
Hello, Torless.
And if I unmute myself, it works better. So thank you very much. This is a lot of great work, and I'm always wondering how to actually validate this stuff, right? So, beside, you know, people with hopefully insight looking at it and providing feedback, are there any, you know, implementation or other validation plans beyond just, you know, manual review?
So I don't have an answer to that. Maybe others on the team have an answer to that.
Can you talk about the validation that you've already done?
Well, I mean, the validation that we've done is Yanglint validation. So, but you are still with Yanglint validation. You are basically doing a you're exercising the model, but it's still up to someone to say that, you know, you've got all the pieces in there.
Right. I mean, so kind of, is the stuff in the model necessary and sufficient to actually, you know, operate a running DETNet service, right? Any running DETNet service, even if just a simulated, emulated, whatever one, right?
Yeah. So, I mean, as far as IP and MPLS, we've used standard models and pieces like that. So we think it hangs together, but I don't have a specific implementation of it. And there might be others in the group that are participating that have been, you know, taking it further. But.
A comment from Andy that he's being serious about SVG, and that is the way that the XMLv3 RFC format allows you to include graphics in line.
Okay.
With that, we have 30 seconds left. So final words, Don?
I'm good. Okay.
János?
I just want to say thank to the whole team working on Yang. It's a really great job and a major piece. And thank you Don for the walkthrough.
I certainly agree. With that, we will see you tomorrow at the same time, again for a 1-hour session.
Okay, thanks. Bye-bye.
Thank you, everyone. Talk to you tomorrow.